was just practicing factoring out the common factor, right? Okay, everyone get your notes back out. I don't want people doing their homework right now. I want you taking notes, paying attention. Got your number. Yes, you asked me that. Oh, so 19 is the same, yeah. Yeah, only negative and when they're both squares. Okay, so we did factor by grouping. So now we're talking about factor in quadratic form. So one of the things we said we knew at the top, which we were slightly rusty on, was factoring trinomials. If you have x squared plus 5x plus 6, how do you factor that? That was from chapter 4. So extending that into chapter 5, now we're talking about polynomials. We're talking about things that might have powers greater than 2. In fact, more than likely going to have powers greater than 2. But we can factor like we did then. So it's that's why it's called quadratic form. If it fits a certain form, then we're going to be able to factor. So let's just try one. I think it'll make the most sense if we just do an example. 3m to the 12 plus 54m to the 7 plus 51m squared. By the way, I'm going to put on this one 3 terms. So if we have 4 terms, we're going to jump to factor by grouping. If we have 3, we're going to try something else. Okay, so here we have 3 terms. But the first thing we always do is check, is there anything common between the 3 terms? M squared. They all have a 3, and they all have m squared. So 3m to the 12 divided by 3m squared is going to be m to the 10th. Remember, we subtract exponents when we divide, because basically what we're doing is dividing. Remember? Awesome how all this comes together, yeah. I knew that's what you were. Okay, 54m to the 7th divided by 3m squared is going to be what? What is 54 divided by 3? 118. M to the what? Let me call on you. M to the what? Mackenzie Horn. M to the 5th, yes. Plus 51 divided by 3 is going to be 17. M squared. We don't write that because m squared divided by m squared is just 1. Okay. Now we have 3m squared, which is done. We can't do anything with it. And we have this here. Now, this is where we're going to talk about quadratic form. You can factor in quadratic form if the degree is twice the middle exponent. Okay, so in quadratic form, we always had x squared plus something x plus a number. So we always had x squared, x is the middle term, and no x on the last term, remember? So this is going to be the pattern, is that we're going to have the degree, the highest power, is going to be twice the middle power. That's what I mean by the middle exponent, if we have it in the middle order. It's going to be twice the middle, and then this number isn't going to have one at all. Now let's just think for a second. If this were m squared plus 18m plus 17, how would we factor that? We would say, what are the factors of 17 that add to give you 18? What are they? 17 and 1. So we would have m plus 17, m plus 1, right? Okay, so how is that going to change? Well, we're still, 3m squared is going to tag along. We're going to have m to the something plus 17 times m to the something plus 1. So it's going to stay. But what is the something going to be? What's the exponent going to be? When we multiply these together, we need to get m to the 10th. So what do you think it would be? What happens when we multiply bases with the exponents? What do you do then? Add them. So we're going to have 5 and 5. And actually, it'll work out that way every time. It'll always be half of the highest power. Just like in quadratic form, it's always half the highest power. Do you see? Okay. Remember, This is only in quadratic form if this first term, the highest power of x, is twice the other power of x, or m or k or whatever letter we're talking about. This number won't have one at all. So actually, if we go back and look in the beginning, it wasn't in quadratic form. Because we have an m over here, and 12 is not twice 7. Do you see that? Okay. Let's try a few more examples. Let's do a to the 4th plus 7a squared plus 6. Oh, I didn't focus it. I didn't tell you. I forget that I refocused this when we start over. Okay. So a to the 4th plus 7a squared plus 6. Now, is there anything common between 3 terms? No. So now we notice that there are 3 terms. So which one was our 3-term technique? Was quadratic form, right? Okay, so is it in quadratic form? Yes, because this exponent is twice this one. This number doesn't have an exponent or a variable. All right, so we have, what are the factors of 6 that add to give us 7? 6 and 1. And remember, I'm going to take half the first exponent. So a squared plus 6, a squared plus 1. Can I factor this anymore? No. A squared plus 6, a squared plus 1 might look like difference of 2 squares, but what part is it missing? The difference part. The sum of 2 squares, and we don't have any way to factor that. Are you good? Okay, someone tell me, what is number 22 in the book? No, not 22. What is 26? Minus what? 24. Okay, let's do this example. Sorry, someone is borrowing my book, so I can't see what it is. Okay, is there anything common between the 3 terms? No. Is it, okay, now we notice there are 3 terms, so that would lead us to believe quadratic form. Is it in quadratic form? Yes, it is. How do you know that, David? How do you know that it's in quadratic form? Do it. Can't hear him. Okay, well, it's to the 4th power, so it's not quadratic. But how do we know that it's in quadratic form? Chambers, how do we know it's in quadratic form? The highest power is twice the middle one. This number doesn't have a power. Yes, good. Okay, so now, how are we going to factor this? Well, this is one of the a times c ones. You have to do a times c, so 3 times negative 24 is what? It's the same thing as, 6 times 12, 72. So huh? Oh, okay, negative 72. What are the factors of negative 72 that add to give you negative 1? What are the factors of negative 72 that add to give you 1? Or negative 1, actually. They're going to be right next to each other. Yes. 8 and 9. Okay, so we would have negative 9, positive 8, right? To get negative 1. Okay, now we have to rewrite it. So 3s to the 4th minus 9s plus 8s minus 24. Sorry. What did I do wrong? Does anyone see? What? No. I rewrote this term as negative 9s plus 8s. What did I do wrong? You do. Because these have to add together to get you back where you started. The way I had it, it would have just been s, not s squared. So be careful about that. Okay, now, what's common between, now we're back to factor by grouping. What's common between the first two terms? 3s squared. What's left? S squared minus 3. So negative, okay, so 3s to the 4th divided by 3s squared is s squared. Negative 9s squared divided by 3s squared is negative 3. What's common between the second two terms? 8. What's left? S squared minus 3. Okay, how am I going to factor this? Here's my two terms. What's common? S squared minus 3. And then what would be left would be 3s squared plus 8. Can I factor it any further? Well, sort of. There is a negative here, but it's not two squares. 3 is not a perfect square. Okay, I don't feel like you're very comfortable with this technique, so maybe you need to practice this one. If you need extra practice, you can always practice the evens. How do you know if you got the right answer? What about the evens? What if you practice the evens? How are you going to tell if those are the same? Yeah, multiply it back out. You distribute this back out. Did I get what I started with? Okay? So please, 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 if you need to rewatch the video, if you need to practice more, do something, because I don't want this to get you behind. All right. For the rest of the time, I'm going to let you work on just a few more homework problems.